This module is going to introduce our first three statistical measures, mean, median, mode, which are used for finding the middle or expected value for a data set. We'll also talk about how to choose which of the three measures is most appropriate for a given data set. Let's get started. So you have shown here a bar graph that has heart rate, the percent of time an individual's heart rate was at a given level during a workout. We don't have the raw data, but just looking at this, we might wonder what the average heart rate is of the individual during their workout. Some of you might assume that it must be at the highest bar, and some might think because of the skewness of the data set, it's pulled a little bit lower. Okay, both of these answers could be correct depending on which measure of central tendency we're using, depending on if we're using mean, median, or mode. And we'll talk about how each is calculated and which are affected more by skewness and outliers. We'll start with talking about the mean first because it's our most common measure of central tendency, and it's one that we think of most often when we hear the word average. So the mean for a quantitative data set is found by adding up all the values together and dividing by the number of values in a data set. We're going to introduce some symbols, some statistical symbols here as well. So when we have a population data set and we're calculating a parameter, we use the Greek letter mu to signify mean. We always use Greek letters for parameters. A mu looks like a U with a bit of a tail on it. Okay? We see the formula here as well has this big Greek letter that looks kind of like an E. That is the Greek letter sigma. Sigma stands for sum in mathematics. So it's saying we calculate the mean by adding up all of our different data values and dividing by the population size. Okay. When we have a sample data set, the symbol we use for mean is X bar. It's a letter X with a bar over top of it. And again, we see the formula says that we add up all the X values and we divide by little n. Little n in a statistical formula stands for sample size. Okay. Whenever we're calculating mean in this course, we're going to round or report it to one more decimal place than what our data was presented in, one level higher of precision. So let's do an example to get started. So we want to find the mean of the following set of numbers. We're going to assume it's a data set and our values are given to us. So to do this calculation, because I'm calculating mean and it's a sample, I'm going to write X bar is equal to, and then I'm going to add up all my values. So 3 plus 3 plus 5 plus 6 plus 6 plus 7 and so on. So we end up getting a total of 63. And I have to divide that by the total number of values I have in my data set. And I have 10 values in my data set. So that comes out to 6.3. Okay, I can write my final answer like that. Notice, so I've got one more decimal place than in our raw data. This data doesn't have units, but we would include units if we know what they are, where possible. and they would match the same, whatever units the data is measured in. So if it was length measurements in centimeters, then the mean would be reported in centimeters as well. Excellent. So our mean calculators are fairly straightforward. So there's 2 more practice questions here. Give them a try. Pay attention to whether they're sample or population data sets. Do the calculation, pause the video, do the calculation, and then check your answers. Okay, great work. So the answer for the first one is mu is equal to 15.8 because it's a population data set. We're representing mean by mu. For the second example, we've got the DNA extraction for a sample of 5 technicians. So we're using X bar for mean. X bar is equal to 4.784 hours. Notice that I'm reporting my answer to 3 decimal places here because it's 1 more decimal place than what the raw data was in. I'm also including units since I know what my values are measured in from the raw data. Great work. Okay, so our mean value is our most common way of measuring central tendency. The problem with our mean, though, is it can be highly affected by outliers. If we look at that second example there, and we were to actually order the data before we calculated the mean, if we think about putting in an order from lowest to highest, right, we notice that the mean value that was calculated isn't really in the middle of our data set. Instead, it's actually between the 4th and 5th piece of data. And the reason why is because we have a value that is an outlier in this particular data set. An outlier is a data value that's a lot higher or lower than the rest of the data sets in our particular set. So 7.95, right, was a much higher value compared to the other values in the data set, and that pulls the mean higher than what we'd expect. Okay, if you have any questions about this, don't hesitate to talk to your instructor. The next video we'll go over median, mode, and look at, again, choosing between our different measures of central tendency.